So hi guys, good evening everybody. I believe I'm audible and I don't know. मेरी शक्ल तो
Yes, sir. Good evening, sir.
Good evening guys. So please drop me a message over the chat window if I'm audible, and the screen. I've shared I think two things. One is that web browser where the message is written, and another one is that PDF that I downloaded from somewhere. Wonderful, great guys. So let me tell you something about today webinar. So this webinar is divided basically into two different things, right? Two different upcoming webinars. Okay. So today we are going to have a glimpse that what exactly we are going to do in the next webinar and what a kind of preparation that you can do, right? So simply before starting this thing about microservices and the new generation of application development and deployment, I really want to give you some 10,000 feet idea about how the world is designing applications and how we are going to handle all this, right? So I hope uh, around 40-50 people are here and we'll be doing number of things here. So this is our website lnbcore.com. I'm sure that I have shared this. I have to do this again. Right. Yeah. So just give me a confirmation that you can view the website also, the one that I'm right now at lnbcore.com to yes. Okay, wonderful. So it's really important because maximum one share. Okay. So I hope yes, it's visible. Yeah. So if you go to webinar right there, you'll get two things, right? You'll get two things, right? And what two things? The first one is this, that is today we are doing. So about the microservices and its upcoming new age of technology and the people, how they deploy applications. Second thing is, after completion this webinar, the next one that we are having around 20th Feb, 3 hours, Saturday, Sunday, 3 hours, right? And where what you will be doing, that is a prerequisite for this. Okay, so simply if you go here, we'll be having a lot of activity practically. We'll be getting involved in all this. So here you have a lot of things to learn, because I think around 6 hour webinar we have. So about this is the content of final webinar that we will be having on the next 20th of Feb. I'm just sharing this link right there. And yeah, by the way, I'm Ashutosh Singh. I'll be your instructor for this particular webinar. And what's up? Hello, guys. You are doing great. Okay, wonderful. So I really want to give you some, idea how we guys are designing applications and in this world. Like if you talk about Netflix, Amazon, Flipkart, and they are changing their entire method. Okay, and why this is important? Because once they change their method, they have to think about number of things like high availability, scaling, and so many things. So my topic for today webinar is microservices. Okay, so let me write it down here. Okay, I already have slide. Okay, so guys, please mute yourself. That will be really great. Wonderful. Okay, so how we're going to understand this and how the things will be happening to understand the word of microservices, I need to take you through the journey of past application deployment model. Okay, so first of all, let's assume that we are having some application. Okay, we are having some application, and that application you want to test, build, or deploy. When I say application, that can be your normal sample code. Okay, that can be your normal sample code, or that can be your a very wonderful website, any web application, or it can be any bigger project. Okay, any bigger project. So application abbreviation for this particular webinar is this only. Okay, I want to build it, Okay, you will understand this soon, what is built. I want to, test, understand this also, and I want to deploy. Okay, today we will be not talking about the development part, but definitely in the upcoming webinar that we have, so we'll be talking about that. So if I just open my one more slide that I created anyhow by working so hard. So if I just go down right there, I want to give you some idea how we deployed any application in this model. So I am sharing this screen also. Yes, right there. I hope this the screen with this PDF, that is how to deploy a web application, something like this. This is pretty much visible to all of you. Okay, I mean, if you guys are there and you can see that, please type yes message. Anyone can type just to get the confirmations. When my team can type, yeah, wonderful. Thank you, thank you, thank you. Okay, so let's see how we used to deploy applications in the past. So we have to go to the market, and any server, any company who do provide one physical machine, then another team who used to install and manage this operating system thing. I don't like this, right? And then they design an application, they install the platform. So for example, if I can give you something, if you want to run your Java code or Python code or Golang code, what do you have to do? You have to purchase a laptop, install OS, install Python, and then run it. So that's how, I mean, entire this process was a time taking. Okay, and what was the drawback that you can clearly see here? Okay, so slow time, definitely. Purchasing and set up hardware, installing OS, and everything is going to take time. Wasted of resources, because you guys know that when you purchase a laptop for your gaming purpose, right, you do code very less, but you do play game a lot, so you're wasting resources in terms of learning. But anyway, so these are some limitations that we used to have in the past. Okay, so no one want to invest much in just sample application deployment or maybe bigger application. Okay, so, and why is there? You can understand this thing as well, because when you have a bigger server, like Amazon is offering a big server, right? 1000 GB RAM, 100 core CPU, a number of things. So one application is running and the entire resources are not getting used, so it's a wastage. And difficulty in scalability, right? It's very important to understand that this particular slide is saying difficult in scaling. Okay, the hardware cannot be scaled automatically. You have to go purchase and set up another. Then I can say I have two hardware, right? For example, I purchased one and now I have two, so I have two hardwares. And vendor locking, maybe you have some driver issues, some OS issues. For example, let's say Microsoft is saying I can be only installed, I mean my OS can be only installed in IBM machines. What the hell is going on? I mean, this is what means vendor locking means. Number of software, number of operating systems are there, and who have their fixed pattern to install and fixed setup of hardware. Okay. For example, in generally in Windows, Dell hardware, you cannot use Mac operating system in much easier way. I'm not saying it's not possible, but in general, you cannot use. That's what vendor locking. So the solution came in the picture. Welcome to the world of virtualization. Here, you can see clearly one physical machine can be divided into number of VMs. I'm pretty sure that maximum people whosoever attending this webinar, you are already having some idea about your VMware, VirtualBox, ESXi, Hyper-V, KVM, any other technology that you do use to run more than one operating system in your laptop. So for example, if I have Windows 10 in my base system, I want to use one more, definitely you can use Hyper-V or any other virtual machine technology. So the solution of this bare metal means hardware based OS, we got this by this one. Okay, so we don't have any problem with this. But the topic that we are talking about, let's say going back to another slide, which one I have is this right here. Yeah, microservices. So how this idea is coming in picture. So once upon a time, I was working with Red Hat India for a project, and with some colleague, right? And there was a two problems I faced. Okay, so for example, if I am a business startup company and I really want to do something like, okay, just give me a second. I hope it's all visible. Okay, now the screen is visible, I believe everybody. I mean, because I'm at writing pad website or app.com. Yeah, no, yes, okay. Yes, wonderful. So at the time, I was working with Red Hat India for a project with my few of my colleagues. The problem was, let's say you want to design your website. So what we used to choose, let's say me and my friend, maybe he knows PHP in a better way. I know HTML in better way. So I can code my entire web application front end. Okay, and this guy can code backend of my website or our website. So generally, when we want to make some dynamic web application, we used to have a mix of front end and backend application. Whosoever they are not developer, they don't have to worry about what is front end and backend. A complete website that has user ID, password, authentication, that has UI, UX, and everything. So something that you can see is front end, but who is working behind the scene, that is backend. And I have some database. This is, let's say, my MySQL or Oracle DB, and I was working like, yeah, see, so they both are individually going to connect with this thing. So when we design this architecture, how we deployed it. Okay, the term, when I say deploy, you can also assume as host. When I say deploy, okay, when I say deploy, you can assume this as host. Okay, so the moment I want to deploy or host this web application, what I did or what people used to do in the past, that's what I have just given that link. So what we did, me and my friend, we purchased one hardware, and here, when we purchased the hardware, there was one guy who installed operating system here. So a guy who installed OS. Then on top of this, I installed PHP plus some web server that can host my website. So that web application that we designed, web app, I hope you remember, and that was designed in HTML and PHP as a backend along with database. So we deployed web server, we deployed MySQL right there, and I have deployed this website. Okay, even if I deploy either in bare metal means simply a hardware machine, or even I can deploy in any cloud VM, cloud-based virtual machine. So if anyone, you are from this background that you have shared your experience with some company or maybe from yourself, that you have a website that written in front end and back end including database. So what you did, you took one OS, anyone, Linux, Windows, or Mac, you install your web server or MySQL, PHP, and you hosted that web application here. People who are from second year background, I mean, in BTech life, they might have have some knowledge about XAMPP, LAMP, or WAMP. Okay, so what is this one? It's a cross-platform Apache MySQL PHP, Linux Apache MySQL PHP, or Windows Apache MySQL PHP. So by using this framework, you can design, I mean, you can host your website here. That is the most simplest way we used to do that. But anybody can let me know what could be a problem in near future. Okay, by the way, I can tell you one thing. These days we don't expect problem first. I'm sorry, these days we don't wait for problem to occur, we plan it. Okay, we plan it. So, okay, we'll be doing that, Saurav. Yeah, MySQL is simply a database. Okay, so if anybody can, just think about it, what could be a problem in near future? My website is running really smooth. Okay, any website that designing this, and I hosted this on a one single machine, and the entire XAMPP, LAMP was set up. So I did all the setup, and everything is going on. Okay. So the one major problem that you can really understand here is simply, if by any chance, your web server is down. Okay. So what are the most possible reason that website could be down? Number one, either the web server is down, maybe lack of resources, maybe database server goes down, maybe the entire OS has some security bug issues. Somebody, injected something in your OS, and now you're not able to, do anything much better way. And the most typical thing is, let's say your hardware is crashed. So we're not going to talk about the last case, that is hardware crashing, but these are the reasons. Okay, so this was a traditional way where I can put my web application in one single machine, or maybe that. So solution to this, okay, I'm coming to microservices, don't lost anywhere, right? Because this is really important to discuss, to understand the microservices thing, right? So because we have these many problems. Problem number one, web server crashing, database crashing, OS security issue, maybe the bare metal. So let's avoid this. So what we did, we given that expanded solution of this thing. So what we did now, for a betterment of my web application, what I did, I took two VMs, two virtual machine, OS1, OS2. Okay, and this OS is having my web server, and this is having my database server, any database. Okay, it doesn't matter, either you took MySQL or Oracle or any other. Okay, so what I did, I take two machines. So for example, to show your website in your college or in your professional life, you have two friends. One is hosting your front end part, HTML, PHP, or HTML, Java, HTML, Python, Go, Django thing. And the second thing, your database is running in second. Now you have less chance of crashing. See, because if your database is down, still your, the less part of website, that is front end, is working. Okay, and for example, the benefit of dividing these two things into two different machines, if you want to upgrade or install something here, that is not going to disturb your DB, and if you update something here, it is not going to disturb your web server. So dividing them into two different component or two different VM or OS is giving you two major benefits. The entire website is not going to crash because we have less chances. Okay, and the second thing, if you do some security update or some backup planning, something that is not going to happen on the real time on the both things. Okay, still we are not up to the microservices. Okay, what we have done, we have divided my major component like this and this to here. Okay, so when we divide it like this, we are saying we have a better approach. So here, number of problems we are having, still we have number of problem. Okay, so yes, wonderful. Okay, so now to understand or give you more suitable example to understand microservices, I'm going to take the example of, I mean, in the same continuation, example of something. For example, me and my friend, we were designing a web application for a most popular website, that is Netflix, streaming app, right? You know that, Netflix. Okay, and any company or any application you can assume. Netflix, let's say, offer images. Let's assume, right? Although it doesn't, it offer live movie. Okay, that means you can just do streaming, and you can do streaming on a static movie. It offer a kind of, let's say, for example, some stories. These are four different things that we can say Netflix is offering. Okay, although it is not offering everything, but let's assume that. So when I'm browsing netflix.com or my app, how this entire thing is going to manage this kind of idea and example or a kind of deployment will be doing. Okay, so if I explain this by using that slide here. So for example, what I can understand is my front end can be designed for this Netflix example. I'm here. Okay, Netflix. My front end of application can be designed using your all the HTML and that part, HTML and all these CSS, JavaScript, and many more things like that. Okay, so for example, I want to use a database. I want to use a database. That database is MySQL. I have done a lot of research that MySQL is best with PHP in terms of connecting and authorization. Okay, it is best with PHP. But let's assume MySQL has a drawback. It cannot store data, or it cannot process 20,000 queries in a second, for example, right? I'm not giving any exact figure. So because there was a content in my Netflix application, let's say a web series that is more popular these days, and this database is not handling that traffic in much efficient way. So my user experience is bad on that. Okay, so what I did, I deployed one more DB, one more database, and that database, let's say the database is Oracle. Okay, and that is best with handling request. But the point is, PHP is not that much good with Oracle. Let's assume, right? These figures are not exactly up to the mark. So PHP was really good with handling MySQL, getting connection, easy grabbing and every single queries. But the limitation with MySQL was it cannot handle too much queries. I found by Googling and by contacting to my friend that yes, they're saying, what the hell are you doing? Okay, go for Oracle, man. But the point is, rest of my Netflix content, let's say other videos, other images, and the other stories, they're not getting browsers much. So definitely, when I don't get much traffic on the other content, I want to maintain this also. Why should I upgrade this when I'm really fine with that? So what I found is, I found that much that Oracle is good, Oracle DB is good, but that is not good with PHP. So by Googling or by taking some consulting from big experts, what I found is if you can use Java is really good with that. Okay, so I have one specific series, let's say dark. Okay, I'm sure that maximum people must be aware about the dark web series, right? At Netflix and maybe Stranger Things, anyone you can assume that is getting browsers much. Okay, so for that particular link where let's say netflix.com/web series/dark, that is getting browser much. Okay, and I want this database. But the point is, this database is really good with Java. So I need to sit with my developer and ask, bro, or maybe not bro, why don't you code only that part of my code that is only for dark web series get handled by Java backend. And for this, I want to use Oracle DB. Okay, and that's really going on. Okay, just stay there, right? Now, after some time, one day Shah Rukh Khan came in picture, and maybe any big actor you can take, let's say any other, okay, came picture, who want to make a live video conversation with people. So they want me or my Netflix team to say, please do host a live streaming netflix.com/live stream. What I found, the streaming server is really much better with Go language. So I have some of my streaming server, whosoever don't understand streaming means like you are watching YouTube videos. So where YouTube videos are stored and by some server, like the one example I can give for open source, Wowza. Okay, Wowza. You can go for Wowza as a much better streaming server you can go for, and that can connect with your this streaming. So I have number of, let's say, 100 videos in my Netflix, and where I need streaming server. But the point is, streaming server connectivity with my Netflix app or website was not that much good, secure, or anything you can understand. So that means I need a best solution. I cannot go with the optional thing. For example, I can go with PHP, but PHP is not best for streaming. I can go with Java. Java is good for DB with Oracle, but Java is not the best option for streaming. Because what I want is, I want to give you the best experience ever to all my user. So I found by, because there is upgrade in technology, anything. So this is best for connecting this. So what I want netflix.com/livestream/SRK. And whenever the audience came here, this particular code of website or application, I want to handle by Golang. And Golang is best with connecting with streaming because it had gRPC and other things. Okay, don't go for that words, but it is the best one, right? One day what I found, I want to show you some glimpse of trailers. So I have one more Netflix tab, netflix.com/trailers. I know in trailers I'm not getting that much traffic, so I don't want to invest Oracle DB. I don't want to invest in database. What I want, I can create one more thing. Let's say I want to do that with Python. That I don't want to do that. Python is best with, for example, sockets. So because it's a very tiny videos, 1 or 2 minute videos, 3-5 minute videos, so that socket can handle the entire thing. So for a bigger streaming, I purchase this one because when I have less traffic, so I need low streaming server. So I'm not investing much in a bigger budget. You can think about it. When people are investing, some startups like Netflix or Spotify, to make them popular, they have to think in a different way. So for trailers, I believe 50,000 connection is fine, and I found that 50,000 Python can handle easily, and I can find so many developers in Python because you have to understand the technical management and the costing way also. Because for streaming, I don't have to go for a developer who is pro in all this. I can do this by Python. So what my point is, if you think about netflix.com is having number of sub options: streaming, live, series, videos, images, content, anything. And what I analyze by researching in technology, that particular link, let's say only login, just to log in netflix.com, my ID is unchecked by me, password something you can try, and that connection is well handled by PHP. So only that stream part I can handle with that. But when people are querying for a particular web series and my PHP is breaking my code, because PHP is not better with handling those many connections. I found a solution of Java. So my point is, layer by layer, my services, my technology is getting changed because of the need. I am not saying I need this, because that much traffic, that much content I had initially just for logging purpose, that was really okay. But now I found that Java is smug. So simply, I cannot write entire code in Java now. Why should I? Because it's a waste of time. And who will sit with those developer? And one day after Java, let's say Golang came in picture. So when I can understand this particular limit set can handle by Java or PHP, but if the things got increased from this to this, I don't have to recode entire my application in Go. The rest thing is getting handled. If there is a new thing coming in the picture, I can code only that part of thing. Let's say, for example, I get 1 lakhs traffic per second, and that much cannot be handled by PHP or Java, for example, right? I'm not going for any facts. And I found that yes, there is a new language in the market that is Go, and which is handling this. But this much traffic I'm getting once in a while. So why should I code entire my application in PHP or in Java, in Python? As per the demand, as per the handling, I can keep upgrading my application, not the entire application, that particular string. Okay. So if this thing is really somewhere you are getting it in your mind, I don't know how many of you, but I'm sure you guys are really smart. So if you can give me yes or no message, no is always, most welcome. But I mean, few people, if you're understanding that, I don't know how far we can go in this conversation. So I can see few messages. Okay. So in a nutshell, let me summarize it, what I'm trying to say. Okay, simply. If someone has some question, please do type on the chat window of your Zoom. So what I'm trying to say is, it's very simple. It's very simple. You guys are from college or from your office background, think about it. For example, there is a project in your college, in your office. If you guys from professional background, you have number of colleagues. If you guys are from college, you have number of other. So what you do, you make a team to perform one task. Let's say you want to win a finale. I'm a guy, I have one of my friends, so I'm good with dancing, for example, although I'm hell bad, but for example, okay. And one of friend is good with guitar. Simply, we are dividing the task as per the talent. Okay. Rather, what I am not doing, I am not learning guitar right now, or maybe dance and singing. So we divide the task, and we make a team. That's what you have to do with the web application. So for example, I have netflix.com. I know these are the conditions. User login that can be easily handled by PHP. But when we have so many browsing and so many data, PHP is really, cannot handle that. Java can do that, but Java is not good with MySQL. Well, I mean, they have NT, so they can, interact with Oracle DB. So for only for that task, I should, go for Oracle. Now the point is, what do you think where we're going? The point is, if I go back, we have these many technology: Python, Go, streaming, browser, AWS streaming, RDP, RTMP protocol, PHP, MySQL, Oracle, so many technologies. And there is no list, right? If I go up a little bit, how I started, see, if I'm going to install and configure all those technology in one bare metal, one host, hell, right? That means simply there will be some issues with the compatibility. Maybe Python and Java, they are not compatible. Maybe MySQL, Oracle, they are not compatible. Okay. And maybe if I divide in a VM, okay, solution, what I can do, I can divide into number of different OS. So let's say on demand, if you are going to take all those technologies, so ideally, because because in future there will be upgradation, downgradation, security, bug fixing, number of things will be happening. You don't want to be on a toss for a particular, URL or website. So rather than deploying in a single machine, we can have number of machines. So welcome to the world of microservices. What is microservices? Dividing your application, any kind of application, into smaller component for a particular purpose. Okay, so let's say today someone gonna ask me, sir, can you tell me facebook.com written in which language? By googling I found in PHP backend, front end HTML. What the hell? No, it's not going to happen, right? These days Netflix, Facebook, Google, YouTube, every single website or big startups you can see, under the line, for a single application there are a number of technology going on, because individual technology, language, server, and number of things have their own role. So these small boxes are the operating system or the environment where, let's say, PHP, Python, database, web server, Tomcat, Apache, Nginx, security system, backup, Golang, they are running individually. Okay, and why? Because because so that we can have individual platform, and when we have individual platform we can configure them. So installing on a fresh machine of Java, Python database is really not a big deal. Okay, so what is the meaning of microservices right now in a nutshell? Dividing your application or setup into number of individual smaller component to handle particular things. And the reason is, let's say you have some problem with your database, so a MySQL, so you have to only go and troubleshoot this particular OS, not the entire OS of one single server, right? And simply when I am doing troubleshooting, only that part is not working. For example, netflix.com, so that something is not working, but rest others are working fine. They are on the individual machines. Why is that? And there is one more benefit, right? For example, my dark web series is getting more popularity, and dark web series was handled by Java and Oracle. Let's say Java is now not able to handle traffic, so I can increase more Java machine, one more server. Only this part, when I am getting a lot of popularity here, only this part I have to scale up. Java instance, Java, maybe in the backend database also. But the entire website, other parts are static. I don't have to, increase this. But that thing is not going to happen when you have a one physical machine. If you scale it up, the RAM CPU, entire thing is going to, up. Fine. So, okay. Now, I hope you have a little minor idea about microservices, dividing your application component into number of pieces to handle particular problem according to the situation. So if you get some idea about it, I'm not saying it's done. I'm done with microservices, but yeah, Nupur, it's getting recorded, guys. You don't have to worry about. Okay, so it will be really great if you can give a little bit response in the chat window, yes or no. I mean, if you're getting even 0.0000001% idea about microservices, say yes. Okay, wonderful. You guys are awesome. So technically, we understand this. Okay, now in microservices, there are a number of opportunities in the market. But, what is the root cause? I mean, what is the problem that we are going to have here? So user-wise, Netflix users are awesome. Oh my God, how fast my browsing is. Even Geo 2 kbps can handle that, small streaming thing. You can assume, you can think about that, right? But in this all story, when the user have this much better experience, who is going to bear the pain? Who's going to bear the pain? The point is, who is going to bear the pain? The investors. The investors. Why? And the technical team. Because let's say for PHP, I'm going to Amazon Cloud, Azure Cloud. Please do launch one OS with this much GB RAM and CPU for my PHP. I have to install this. Okay. All right. Then after a day, please do install or launch one virtual machine where I can, install Java, configure my code, and blah blah blah. The big problem is cost. Okay. In this all story where the user experience is awesome and getting a lot of popularity because how smooth browsing these days we have, all Netflix user can analyze that. So cost, big problem. Management, who will maintain these many servers for particular, because to give up amazing experience for all the users, we have to manage these many servers. For example, if I have 5 technology languages, 2 server, 2 databases, so at least 10 servers. So at least I have to handle 15 servers, for example. This is I'm talking about 101. But let's say out of 15, one server was for Java. And what if the one server is not handling the traffic? I have to scale to 2 to 3. So that number is going to increase. We have technologies in the market that we can scale it up. 18 servers. I am giving you the most minimum number, right? And installing, management, scaling, this may take time. Management is a big problem. Costing is a big problem. And scaling, handling traffic, or backups and everything, number of problems we have here. So if I go back to my this, I have these many, all the white boxes are servers. Either it is a virtual machine on the cloud or physical machine somewhere, it doesn't matter. So number of people in the market, they have some confusion. Can we design a web application using the concept of microservices with the bare metal? Yes, of course you can do that. I mean, deploying number of hardware, doing all the things, you can do that, but that is time taking process. Rather choose VM, virtual machines, okay, by cloud, by your own. So these are all white dots are virtual machines, okay. So if you think about it, let's say for netflix.com, in my opinion, or according to me, or in my opinion, I believe maybe 1,000 server for a particular streaming. I'm not talking about entire Netflix, for a particular streaming, let's say netflix.com /web series /dark, 1,000 servers. So the point is, who will handle that networking thing? And what if one server is gone, IP got changed, something, so this is going to be a mess, right? That's why if you have these many server and someone got corrupted or deleted or recreated, so the entire IP and maybe definition will be changed, anything new came in picture, so who will handle this mess? So the technology in the market, we call it service mesh, right? So about this, I'll be giving you a few idea in the next webinar that we are having on 20th, I believe. You can check it, service mesh. What service mesh will be doing? I think I got some messages. Okay, right. So let's say if I increase more servers, decrease something, so I don't have to hard code my application as a developer. Please do connect with this server only. No, I cannot do that, because when we have too many machines, too many servers, coding them, their IP addresses, their name, and everything on the real time is bullshit. Okay. By the way, this PDF I have downloaded from Red Hat, and it is for service mesh only. But I'm using it for microservices because I'm bad at creating PDFs and everything. Anyway, but service mesh is not going to solve the problem of costing. It can only handle all the interconnectivity between or among the services, but it's not going to solve the problem of cost. That's where I have to pitch with new and really new technology. So if you are planning to design your application using microservices logic, so for deployment of microservices, you don't have to prefer number one, hardware. I mean, bare metal, directly purchasing a machine, installing all these things. Number two, even you don't have to choose virtual machines also. The reason is number of virtual machine is going to have resources, OS and things. So the best solution these days to deploy is container. Okay, this one. So you have thousand of small servers where the entire thing is going to run as an entity. So you don't have to choose hardware. I am not saying you cannot do that. You can do that, but you don't have to go. And the reason behind that was costing. Hardware virtual machines, they are highly, costing servers. So you can go for containers. Couple of people will be having understanding about uh, containers, but don't worry if you don't have the next session having that much also in detail. So containers, okay. So to design microservices, you don't need container, but to deploy microservices, you really need container to avoid that costing things, okay. And whenever containers come in picture, the story is going to change entirely, okay. And for example, let's say if you want to design your some part of application in Java, so Java has a really popular framework that is Spring Boot these days. You can go for it, okay. So somewhere in a summarized way, in a nutshell, we landed somewhere that these days application designing, if you do it in a microservices style or way, it's really to handle, scale, manage, for a smooth thing. And the most important thing is you can use number of technology. That means a particular part of your web application can be handled by HTML, PHP, other handled by HTML, Java, Python, Go, Oracle, database, load balancer, and this all technology bundle. So because every technology has their best side and have their bad side also. So the best side we can use for a particular thing. Okay, that's what we can do. So now to design microservices, you have to understand programming languages. You can go for Python web application or Java, I don't know, okay, Go, PHP, Node, anything, okay, JavaScript it means. But to deploy, we need containers, okay. So simply now the next webinar is about design. I'm not saying I'm going to design from scratch, and deployment. Okay, design and deployment, simply. So how we design, how we think, how we deploy. Anything, testing or troubleshooting and all things will be doing with the help of containers. Okay, and when it comes to container technology, assume that PDF again. I hope it's visible. Okay, I hope it's visible, right? This microservices boxes. So now you can assume these are not my a hardware machine. These are not my virtual machines. These white dots, a white, a kind of hexagon, whatever you say, they are containers. They are really containers. And where one container is having Python code with the connectivity of database, other Java container connectivity of Oracle, HTML, web server data, everything. And this entire connectivity will be managed by service mesh. I mean, if anything is happening, okay, number of things will be in picture. Okay, so I hope, okay, a question by Yadav G. The prerequisite, I'll be writing it down before ending this session. Don't worry about that, right? I'll be writing it down, okay? So all these things, okay? Now, if we have these many containers, so the benefit of container will be understanding later on, okay? So the benefit of container will be understanding, but containers can be created and managed, created, not managed. Containers can be created by, what the hell? Okay. Oh, can be created by any of container runtime engine technology. Okay. Maybe a couple of people, you will be understanding Docker. So Docker is one of the option to create container. Apart from Docker, you have other option like Podman, you have Cryo, okay, you have Rocket, many more. So not only Docker, Podman, Cryo, Rocket, these are all the technology that can help you to create containers, okay? So for the next webinar, you have to understand at least Docker from very basic, okay? We have another YouTube series here in LNB to give you some idea about Docker. By the way, for this thing, if you want to get involved practically, you have to install Docker in your either Mac or Linux or in Windows machine. If you want to follow me, I mean, designing and deployment of all those things that we are planning next time. So you can install Docker by using Docker Desktop. And this is the link I am giving it to all of you. If you want to install Docker Desktop for next webinar, okay? So this thing, at least you can install it. Installing okay. Docker. Fine. So I am giving that link. I've given it actually. Installing Docker in Windows. Closing it, right? All right, all right. Microservices screen. Yes. Now it's visible, guys. I'm sorry, it was my mistake. Anyway. All right. So, is it visible now? No. So I am at my PDF and now I'm sharing microservices again. How about now? Okay. All right. Yes, sir. Good one. Cool.
No, still no.
Still no?
Yes, still no.
This a black screen with microservices and number of dots.
Yes. Microservices.
I think my Zoom is getting crazy. Let me reshare it again. Okay. Stopping and sharing. Okay. Selecting microservices, PDF, and going click on share. How about now? I cannot.
Same.
Seriously.
It's same.
I think some, yeah, it's visible. You can refresh it because I got some few messages on chat that yes, it's visible. Maybe you can check. I mean,
same screen, sir, same screen.
Where the microservices is written?
Yes.
Okay, that's what we need. That's what we need. Okay. All right. So anyway. So simply this screen we want. Okay. So this where the microservices is. Okay, that's what. I want to share my another screen, and let me just put it here. And now, yes, this one. I believe this time it will be the browser. Okay, I got something, I can confirm that. Yeah. So to understand and design, deploy, contain microservices, we need to understand, Docker technology or any other, but we are preferring Docker for next session. Okay. So I'm not going to teach that entirely, but yes, that technology will be using. Okay. So first of all, if you just see here, I'm just sharing my, this screen here. Yeah. So if you see here, in the next workshop that we'll be doing for 2 days, I think 3 or 4 hours is there. It will be 6 to 9. Yeah. What will be the content flow? Will be, talking and we'll be doing it practically. This thing, kernel deep dive thing, and container model using cloud-based Podman, Docker, all these things. Okay. And Python-based web application will be seeing Java-based, C-based, Golang web application, okay, and all these things. Okay, so these two part will be discussing in that session only, but yes, that we can understand. So to manage and maintain and monitor, scale, everything will be covered in very professional way. Like if you're a pro, you already understand technologies, you will get that. We're planning number of series like that to give you 10,000 feet idea about designing, securing, developing, and deployment of microservices based applications. Okay, so this thing is all set and up to the mark. I hope you got some idea about microservices. We need this thing, and to manage these many containers, because we will be having those many containers. So let's say we have containers, and that will be created by maybe Docker or any other technology. Let's say Docker or Podman. I'll be preferring both next time. So let's say we have 1,000 containers. So these are 1,000 containers, and these containers will be handled by, managed and handled by another technology stack that will be Kubernetes. I'll be giving some idea about other platform also, like OpenShift. I'll be using, not giving idea. Okay, OpenShift. So this is for if you have 1,000 containers, maybe 10,000 containers, how we remember, manage, connect, auto scale, redeploy things automatically. That will be by Kubernetes. Okay, but the point is, who will monitor these 1,000 containers, that this container is having that much resources, this is going crazy, this is having this kind of load, so we need some monitoring also. So monitoring will be doing by using two things. One will be Prometheus, it's Prometheus, and the visualization will be doing by Grafana. So these are the next thing that we'll be discussing, and we'll be doing it practically in the next webinar. Okay, and then how we deploy it, automation, automatic deployment will be doing with the Helm. So I'll be giving some idea about Helm version 1 and 2 both. Okay, along with maybe AWS or Azure cloud. So we'll take some sample microservices based application. We'll code them, we'll convert them into container, Docker, and then we deploy managed by Kubernetes and OpenShift. We'll watch the monitoring performance by Prometheus and Grafana. And automatically, if we deploy in the entire solution in one go, we'll use Helm. Okay. So these will be the things that we will be discussing in next webinar. Okay, that's it from my end, guys. If you have some question, do ask me over the chat and we can go. It was a really short session because I wanted to give you some idea so that whenever the next time I'll be using microservices, it must not be a really pretty new keyword for you, right? So hopefully you got few understanding about the approach I took from our Netflix example. And one final yes or no message you can give, then we can say bye-bye for everybody. Wonderful. Okay, I'm really excited for the next session. And thank you so much, guys. Thank you all. Join next time and have fun.